Welcome back, Algebra 2ers. We're taking a look this time at solving polynomials. That's the big idea here. Solving polynomials. And we've actually seen a rendition of this previously, Chapter 4, when we were applying the zero product property, which allowed us to solve problems like the following, where if we had some factored form of some problem, and it was all set equal to 0, the zero product property allowed us to say, well, since this is a product being taken, x plus 2 would have to be equal to 0, or x minus 2 would have to be equal to 0. So a lot of that's going to come back here where we're trying to solve and factor whatever we can. Now with polynomials, sometimes this will be a little bit more unpredictable as far as what we're trying to do. But if you're a fan of steps, we're going to follow these here. We're going to write the equation in the form p of x equals 0 for some polynomial function p. So again, a little bit of vocab here with polynomial. This just means an expression with lots of terms. We learned about this earlier, where there's some leading term that dictates end behavior. But the key thing is that the polynomial is set equal to 0. We then factor, doing whatever we can to isolate or rewrite the expression, the polynomial, and then apply the zero product property to find the roots, or the answers, if you will. So for this problem seen here, we have 4x cubed minus 6x squared equals 4x. Let's first go ahead and solve and get all the terms on the right side. So let's get rid of 4x here, 4x here. If we do that, that leaves us with 4x cubed, still minus 6x squared, but now minus 4x. This still equals 0. So now that we've gotten all terms to the same side, now we're being asked to factor. So let's think. What's common with these three terms that we could take out? They have 4 and 6. Are there any factors with those? Hopefully you're saying 2. What about with variables? What's the lowest variable we could take away? Or GCF. Hopefully you're saying x. If we rewrite the rest of this, 2x times 2 would get us 4x. We need to add that up to 4x cubed. So let's put in 2x squared here. We're then going to deduct 3x. Then we're deducting 2. This should be equal to 0. You should hopefully notice that we can factor this trinomial a bit further, keeping 2x on the outside. Use factoring by grouping for this. So that's this right here. If you use diamond method, it would look like this. 2 times negative 2 is negative 4. Negative 3 is up top. So the best factors here are negative 4, positive 1. Eventually, if you factor by grouping, you would end up with something to the effect of 2x times x. You would then be taking this further, and then you're starting to break this apart. So you end up deducting 2 because you want to get to negative 4, but you end up adding 1 that gets you here. That's good. So now that this is completely factored, we can solve these and say, well, we know that 2x could be equal to 0. Or the second factor, 2x plus 1 could be equal to 0. Or x minus 2 could be equal to 0. Eventually, if you solve these using algebra skills, isolate x, you can divide 2 on both sides here and here. This claims that x equals 0. If you solve for x here, x is going to be equal to negative 1/2. If you solve here by adding 2 to both sides, x equals 2. So as you can see here, we have 3 answers. A little crazy, but takes a little bit of time. And a lot of this you've already seen. And to help you through this, on the back page, you'll see that there's a general summary strategies for how we can solve these and how we've worked with factoring in the past. If we have to set up diamond method and take it a little bit further, or if we have to take out a greatest common factor like we did with the previous problem. So for something like this, you might have to factor out what's common with all three terms, like 4x and then cubed. This would then go to 2x. This would then have to be down here to just 12. So as you can see from these examples, sometimes these get a little bizarre because there's so much going on, but hopefully this is building sequentially where this all just kind of makes sense. Difference of squares can be a little tricky, but good rule of thumb is that if there are only two terms and you're subtracting, you can take square roots. And then this introduces the idea of sum or difference of cubes down here, which only comes up so much when we have two terms that are being cubed and added or subtracted together. So for something like this, 8x cubed plus 27, 8, well, if we look at that, 8 could be denoted as 2 times 2 times 2, and then x is x cubed up here. So we could really denote this as 2x plus 3. And then as we take this to the right, you can kind of go just about it by saying, in comparison to this, you could say that 2x is going to be a, 3 is going to be b, and then you can kind of follow this algorithm here if you want to. You could eventually say that a squared is going to be 2x times 2x, so 4x squared. You're eventually deducting the product of a times b, so this would be 6x. And then also plus b squared, which is 9. What's cool is that you can check your work on this if you want to, but trust me on it. For this example, we're factoring, even though we could really isolate x cubed and then take cubic roots, but for this we'll play the game, we'll solve by factoring. So let's first move that 54 over. Gets us here. I see a common factor between these two, so we could factor out 2. That leaves us with x cubed plus 27. So we now see that this is a difference of cubes right here. This can be factored further to 2. And then this would be x plus 3, parentheses x squared, minus 3x plus 9 equals 0. So this actually can't be factored further, so we only really have one answer that's real at least. So we could say that definitely x plus 3 equals 0, so x definitely equals negative 3. But if we use quadratic formula on this, we'll soon see that there's an imaginary solution. So if we do that pretty quickly, we're taking opposite of b plus or minus the square root. B squared is going to be 9 minus 4 times a, which is 1, times c, which is 9, all over 2a, which is going to be 2 times 1, which is eventually 3 plus or minus, and then you end up with 9 minus 49, or sorry, 9 minus 36. So this ends up taking it down to negative 27. I think. Wait, is my arithmetic wrong? No, I'm right. 9 minus 30. Yeah, all right. Eventually, when that's simplified, that gets you here. Where eventually you would just say that x equals 3 plus or minus I root 27 over 2, which is pretty extensive. So as you can see here, it's kind of bizarre that we are able to say that these somehow share the same answers.